Intro. Imagine holding a tiny sugar cube in your hand. Now what if I told you that a piece that size, just a little cube of sugar, could weigh about 1 billion tons? And we're not talking about some super heavy material from Earth. We're talking about a neutron star, one of the most mind-blowing objects in the universe. Stick with me as we break down just how insanely dense these stellar remnants really are. So what exactly is a neutron star? Well, when a massive star runs out of fuel, it can no longer hold itself up against gravity. This causes the star to collapse in on itself, resulting in a supernova explosion. But what's left after that explosion is a neutron star. A neutron star is basically the collapsed core of the star, packed so tightly that its density is out of this world, literally. We're talking about a mass that's typically around 1.4 times that of our sun, but compressed into a sphere that's only about 20 kilometers in diameter, roughly the size of a city. Now let's talk about density. We all know that density is mass divided by volume, so with a neutron star, you're dealing with an object that has a mass nearly equivalent to the sun, but compressed into a space about the size of Manhattan. Think about it. If you had a single cubic centimeter of neutron star material, about the size of a sugar cube, it would weigh around 1 billion tons. To put that into perspective, that's equivalent to the weight of about 1 billion elephants, all packed into a tiny cube. Here's the science behind it. In a normal star, atoms are made up of a nucleus, protons and neutrons surrounded by electrons. But in a neutron star, things are completely different. The immense gravity squeezes the atoms so tightly that it forces electrons to combine with protons, forming neutrons. That's why it's called a neutron star, because it's made almost entirely of neutrons. This process creates a super dense material. The neutrons are packed so closely together that there's very little empty space between them, giving neutron stars their extraordinary density. So how dense is too dense? Well, neutron stars are at the limit of how compact matter can be. If they get any denser, they might collapse into something even more extreme, a black hole. In fact, neutron stars are the remnants of stars that were just massive enough to avoid becoming black holes. Anything more massive and the gravity is so strong, not even light can escape. And that's the mystery of black holes, a topic for another time. Okay, let's imagine for a moment that we could actually touch a neutron star, and yes, that's pure science fiction. If you were somehow able to stand on one, the gravitational pull would be so extreme that you'd be crushed instantly, even by the tiniest of movements. And remember, the gravity on the surface is around 100 billion times stronger than Earth's gravity. One step would feel like you were being pulled by an invisible giant. Now, don't worry, we don't need to plan any trips to a neutron star anytime soon, but it's fun to think about the forces at play in these extreme environments. In real life, neutron stars are actually observed by astronomers. We detect them through the radiation they emit, especially in X-rays and gamma rays. Some neutron stars, known as pulsars, spin rapidly and emit beams of radiation that we can see from Earth, like cosmic lighthouses. They give us a window into these faraway objects. Scientists are constantly studying these fascinating objects to understand their mysterious properties. Neutron stars could even help us understand some of the most fundamental questions about the universe, like the nature of gravity and matter at its most extreme. So the next time you eat a sugar cube, remember this mind-blowing fact: a tiny chunk of neutron star material would weigh about 1 billion tons. Neutron stars are a true testament to the mind-bending extremes of the universe, showing us how small objects can pack such incredible power and density. Thanks for joining me on this cosmic journey today. Don't forget to like, subscribe, and hit that bell for more deep dives into the wonders of space. Until next time, keep looking up.